Hello, my name is Preethi. I am working as an assistant professor in the department of EEE in SNS College of Engineering. Today, my video is about power system analysis, real power and reactive power. What is real power and what do you mean by reactive power? Let's have some introduction. Before that, the planning of power system is that in an optimal way is an important task for the smooth functioning in the electric power industry. What do you mean by real power? The real power is nothing but your actual power consumed, that we call as a real power. The reactive power that we call as an useless power, which we are not going to consume any power, that useless power, that worthless power, that we call as a reactive power. These are the main concepts in the power system industry. Let us have some real time example for the real power and reactive power. Real power, as I said, real power is the actual power consumed. Let us have a soda. Okay. In a soda, the actual part is known, that what we are having, that we call as what? The real power. We are having some gas, that gaseous part is called as a reactive power. Okay. And you have to understand about the apparent power. Apparent power is nothing but a total of the real power and the reactive power. So, summation of the active power and the reactive power, that we call as an apparent power. So, here we can say that real power, also known as the active power or true power, is the actual power which is consumed or produced by an electrical device in an AC circuit. It is measured in watts. Okay. So, which we are performing some useful work, that we call as a real power, which is used in various applications like providing the light, driving the motors, or running some appliances like washing machines, hair dryers, etc. Real power is responsible for producing the useful output in an electrical power system. Okay. So, real power is equal to is a product of the voltage and current in the cosine of the phase angle between the voltage and the current. So, real power is the component that is in phase with the voltage. So, the devices that consume real power is called as a active power. The next one is called as a reactive power. Reactive power is also known as the apparent power, which oscillates back and forth between the source and the load in an AC circuit. Real power is measured in watts, whereas in the case of reactive power, it is represented in volt ampere reactive. It is called as VAR. Okay. So, actually reactive power are stored in the form of inductive and capacitive elements in a circuit, in the form of electric and magnetic fields. Say for example, inductive components like motors, transformers and some inductive coils require some reactive power to produce a magnetic field, whereas the capacitive components, example like capacitors, it requires the reactive power to create some electric field. So, I can able to tell you that reactive power does not perform any useful work. Better, my dear students, you have to think about the soda. Okay, what we are actually consumed, that we called as what? Real power. That gaseous part is called as reactive power. A total part is called as a apparent power. It is very easy for you to understand. So, I told you that apparent power is the vector sum of the real power and the reactive power. So, it is represented in terms of the volt amperes. Real power in watts, reactive power in volt ampere reactive, whereas in the case of apparent power, we are representing in volt ampere. Okay. So, you all know about the Pythagoras theorem. It is nothing but in a right angle triangle, the square of the hypotenuse equal to sum of the squares of the other two sides. Similarly, in the apparent power, real power and reactive power, we can have some power triangle, which can be able to see in the upcoming slide. So, in this we can able to mention the real power and reactive power in a complex plane. So, we will have in the next slide for clear understanding, my dear children. So, see here it is the power triangle. Okay. So, in the base, that is x part, you can able to see a active power. It is the cosine of the phase angle difference between the voltage and current. So, P is equal to V I cos phi, and reactive power Q is equal to V I sin phi, and apparent power is the S which is equal to product of the voltage and current. So, this is the power triangle which we are making in the term of a Pythagoras theorem. And what is the summary I want delivered with you, my dear children? The real power is the useful work that we call as a real power. The reactive power is the useless work, nothing but a power that oscillates back and forth between the inductive and capacitive elements without performing any useful work. So, kindly make a note of it. And apparent power means what? Total power flow in the system, nothing but active power as well as what? Reactive power, combining both real power and reactive power. Real power is otherwise called as active power. Do not get confused with this. So, whatever the subject or concept we are learning, application is highly important. So, in the case of applications of real power and reactive power, we can able to find several applications like powering the electrical loads, like including the lights, motors, heaters, computers, household appliances. So, where we are using the actual power, nothing but useful power. Okay. In the case of industrial applications like machinery, operating the manufacturing process and running the industrial equipment, we are using the active power. And also in the case of the power grid management, real power plays a crucial role, and power companies monitor and manage the real power consumption and generation to ensure a balanced supply and demand. Okay. The power generation is equal to supply plus demand. So, we can able to maintain the grid stability and avoids the blackouts. Blackouts means what? Voltage collapse. And energy billing, real power is the basis for energy billing by utilities, nothing but we are consumers, am I right? The consumers are charged based upon the amount of the real power that we are consuming from the grid. So, these are the very important applications where when you take the case of applications of reactive power, it is nothing but used to regulate the voltage. So, in the case of voltage regulation, it incorporates a highly important role, and it is also used for the power factor correction. Reactive power is mainly used for the power factor correction. In many industrial and commercial consumers, it install the power factor correction capacitors to counteract the reactive power consumed by the inductive loads. So, for improving the power factor, it helps a major role, and also for compensation purpose, for line losses, reactive power plays an important role. By managing the reactive power flow, voltage drops can be minimized, leading to a more efficient power transmission. So, it acts as a power compensation, and it also used for a support for inductive loads such as motors and transformers. It is used to give a reactive power and sustain the magnetic fields. Okay. So, these are the various applications for the reactive power, and also used for the enhancing the grid stability, and also used in the application of the capacitor banks. So, these are the various applications in the commercial as well as the industrial side. So, overall, my dear children, both the real and reactive power plays an important role in the efficient and reliable operation of electrical power systems, and also for the utilization of electrical energy. So, managing and controlling the real and reactive power is important task for the smooth operation of an electrical power industry. Yeah, my dear children, I hope so you understand. And now we can have the assessment. Okay. Can anyone differentiate what do you mean by real power and reactive power? You please let me know the answer, and also you please tell me what are the industrial applications of real and reactive power. Okay. So, now I have referred the power.The electrical power systems, and also Shoaib Khan industrial power systems T&F book. Yeah, my dear children, thank you so much.